Hello guys, and welcome to another episode of Motortech. My name is Lewis and I'm pretty excited. We are getting close to finishing this project and this is pretty exciting to me. It's been quite a while actually since I've done an ECU wire up. Same as fabrication. I haven't done fabrication in a long time. It's been like 3.5 to 4 years since I've done some fab work like the intercooler piping and the exhaust dump pipe that you just saw. It's been a while, so I was pretty excited to get back on those tools. And anyways, now we are doing the wiring. Now I'm doing this a little bit different, and to be honest, I've never done this before in this way. I know I just said that I've done wiring and ECUs before, but I've never done this type. And what I mean is that this is an automatic Land Cruiser 80 series, but we need to retain the factory ECU. Now we want to have full control of the engine. So we want to have full control of ignition timing, and full control of our fuel delivery. But we can't get rid of the factory ECU. That factory ECU needs to stay there because it does work with the transmission and the instrument cluster. So we want to try and avoid, we want to try and minimize the work that we've got to try and invest in this when all the hard work's already been done for us with the factory ECU. So trying to wire this in and keeping the factory ECU happy, I've never had to do that before. So all the ones that I've done, I've always been manual for starters. So we haven't had any issues with having to retain the factory ECU to control other components. So it's been quite easy, pretty straightforward. Remove the factory ECU, put a new one in, get the instrument cluster to work with a new ECU, or install an aftermarket instrument display. So there are a few unknowns here, which I'm interested to see how well that's going to work. So the plan is to tap into ECU crank signal and cam signal, but leave the factory ECU as well listening to those sensors. So the ECU will know that the engine's cranking, will know that the engine is running, but it won't have any control over it. Now, in theory, it should work. We might get a check engine light, but I can fix that, that's no problem. But in theory, that should work. So everything else, we're going to give control to the aftermarket ECU. Now, you guys might or might not have heard of this ECU. I've actually had the pleasure of tuning a few of these, and that's why I recommended it to George. So this is a ECU Master. This is a classic. So this is a very basic entry-level ECU. But honestly, it has so many features packed into this little box that it does more than what we needed to do. And for value for money, you can't beat it. You cannot beat it. One of the things that impressed me about this ECU is how direct the feedback is from when I'm tuning it. So I've had other issues with other ECUs that I've tuned where I'm starting to almost chase my tail a little bit, if you know what I mean. You'll make some changes and it'll take those changes and then you'll move on to something else. And then you come back and you've got to make more changes. And so you're sort of chasing your tail a little bit back and forth. I found this just to be very direct. You tell it what you want it to do, it does it, and it stays. So I was very impressed. And the value for money, like I said, it's very good. So look them up. I'm not sponsored by these guys. I'm not big enough to be sponsored yet. Make sure you click that like, click that subscribe, and then maybe I can get some sponsorship deals, right? But anyways, for now, I will give them a good brag. They are a good ECU. So let's have a look at what we get in this little box. All right. So in here, look how cute that is. Look how tiny that is. I mean, you can fit this anywhere. That's another plus. You don't have nothing bulky that you've got to try and make space for under the dash. It's very, very compact. We'll get our two connectors. What else we got in here? Warranty card. We've got our USB cable for the laptop for tuning. We get a set of pins. We'll get some resistors in case you need them. And we've got a little pin diagram card, right, to help us with the wiring. So that's all we get. Not much. So in conjunction with this, we also had to purchase, so that stays with that, we have got a wideband controller, sorry, a wideband sensor. The wideband, this is a big plus. The wideband controller, it's inside of this. You don't have to purchase, you don't have to spend another $400 to $600 on a wideband controller. It's built in. So we bought separately our wideband sensor with our wideband connector. So that'll connect onto the sensor, and we wire this into the ECU. So we got that. Wires. We've got a complete terminated wiring harness. Now it doesn't come with the plugs because we already have the plugs here. So although this is a little bit of work, it's not too bad. So this has enough wires to cover every single pin in these two plugs. Now we're not going to need all of them, right? They give you everything in case you want to use the absolute maximum that this ECU can deliver. So all your extra inputs and outputs, they give you enough wiring for all of that. Now, like I said, we're not going to need all of it, but it's good to have it. So we've got all of our wiring, and we have air temp sensor and a plug to suit. Okay, so this is our minimum. The rest that we need, we're going to get from the car. So, you know, we're going to get our TPS, signal. Like I said, we've got our injectors, we've got our ignition coil, coolant temp sensor. So we're going to tap into the factory one and do the calibration. So we use the factory coolant temp sensor. And that's it. That's the minimum that we need. Later in the future, if George wants to get a boost solenoid, we can control boost with the factory ECU as well. We just need a boost solenoid. But that's it, guys. Pretty simple, great ECU, great value, and I'm interested to see the outcome of what we can achieve with this. I'm pretty confident on the capabilities of this. The question mark is whether we can get both ECUs to share some of these important signals coming from the motor and be happy at the same time. So that's it, guys. Welcome to this episode. If you enjoy this type of stuff, make sure you hit that click and subscribe for some new projects coming up soon. It's not going to be all about four-wheel drives. It's not going to be all about BMWs. It could be anything. I don't even know. So, all right, guys, let's get started. All right, guys, so I've removed the factory ECU. It sits comfortably behind the speaker cover here and the glove box. So I've unbolted it, moved it to the side where I've got easy access to the connectors. I've printed out a factory ECU pinout so I can identify the correct wires, and so I know which ones I need to cut, which ones I need to tap into. And we also have plenty of room behind there where we can hide the new ECU, which will sit nicely, nice and close to the factory one. So as you can see, I've marked all of the pins that I'm planning on using, just with a black texter, just so it's easy for me to find. And then all you do is you identify your wire. Each wire is labeled. So for example, this one is, it's going to be hard to focus, but right there it says injector 1. So we find our injector 1, which is the grey connector, pin 7, which is this one right here. And all you do is you pop it in there, give it a wiggle, and pop it in, and that's it. I've done a few there, and I've got a few more to go. Good morning, guys. All right, so I'll give you a quick update on where we're at. There's been a lot of mucking around with the wiring, back and forth. Nothing dramatic. I did have some issues getting it started, and obviously the first thing that crosses your mind is the factory ECU with the aftermarket ECU. They're not working well together. That's the first thing that crosses my mind. So then I spend a lot of time doing my checks and doing my testings and checking voltages and resistances on both, and trying to program the aftermarket ECU on the laptop to check that I'm getting throttle position, that I'm getting coolant temp, and that I'm getting a crank signal, a solid crank signal. And so there was a little bit of back and forth. Well, it turns out that both ECUs are happy. So the factory computer, it's still, well, I don't know if factory computer is happy. It doesn't bother me so much. So that one's happy. But the aftermarket ECU does start the car. So I'll give you a quick look on where we're at, and then I'll explain what is happening and what we've got to do to fix it. One second, I unplugged something. Make me look bad. Okay, let's plug this back in. All right. Let's try again. All right, so it sounds good. It sounds nice and clean. There's no popping and carrying on. I still got to play with the startup map, so that's actually starting pretty good. It will get a little bit better once I get the tune happening. I just got enough numbers in there in the ECU just to get it running. So it's idling too high. Now I was hopeful that leaving the factory computer to control the auto control motor, that it would have been happy doing that. So it's a stepper motor, but it's not. So just to give you a guide as to what sensors are being shared by the two ECUs. So TPS is being shared by both of them. Obviously, cam and crank signal, they're both being shared. So my tacho still works, and the tacho is being, that signal is coming from the ECU. What else? Coolant temp sensor is being shared. And then obviously we cut off all the injectors, and we cut off the igniter trigger. So we got full control of ignition, we got full control of the fuel. And so I thought that would have been enough, that the factory computer would still sense an RPM and it would want to control the idle. It's not. But also there's no F flow meter, and that could be part of the issue, because there's no F flow meter. The factory computer is not seeing load, and so it doesn't know how much air to allow into the motor for auto control. So now I'm gonna have to cut the wires off the factory ECU for auto control, and we're gonna wire them onto the EMU, the ECU Master, and then we should have full control of the idle, and then we can move forward. The other thing that I forgot to do is to put a bung for the air temp sensor. So there's no, the air temp sensor, I got it sitting around there somewhere. But yeah, I forgot to put it onto the pipe here. So I got to drill and weld there the bung for the air temp sensor. And that's about it, really. Still waiting on a fitting to put right there. That's for my vacuum line for the fuel pressure and for the ECU map sensor. But that's it, that's where we're at. It's looking good, but I'm not gonna get too excited until we actually drive this and it changes gears. That's what I'm hanging out for. If it doesn't change gears, I don't know what I'm gonna do from there. But I'm hopeful that there's not too much technology in this car yet. It's not like a 2020 BMW. Oh gosh. So anyways, that's where we're at. We'll leave it there and I'll be back soon with some more news. All right guys, so I found the problem to the high idle. So this is a stepper motor. So this is a 6-wire stepper motor. So 2 positive and then 4 wires that control the coils, which change the polarity of the little magnet inside that causes this little plunger to turn clockwise or anti-clockwise, and it's on a thread. So when it turns one way, it'll close, turns the other way, it'll open. So after checking everything, checking the wiring, I got on the phone for technical support for the ECU and checked it, and everything was okay. We tried a few different things, but nothing fixed it. So then I pulled it out and I pulled the top apart, and the actual little threaded section, I don't know what to call it, the little threaded section that's meant to rotate to push this up and down, it was just flickering back and forth, but it wasn't rotating. And then after taking a careful look at how it works, there's a bearing that it sits on. So it's got a plastic housing. That plastic housing presses onto a bearing. That bearing wasn't rotating. So I could just get it to move back and forth, wow, probably half a millimeter. It was hardly anything. And so after I made sure that it was a bearing, sprayed a little bit of WD-40 in there, and I just worked it back and forth, and I applied a little bit of pressure with the screwdriver, and I got it free. So I got it to rotate freely. I plugged it back in just on its own, and as soon as I turned the ignition on, it spun all the way beautifully. So I'm about to throw this back in, and hopefully now we've got some idle control. Okay, let's see what happens now. Guys, after getting the car running, idling, and had everything sort of going all right, I thought I'll check the fuel pump. So we did, as you saw earlier, we did upgrade the fuel pump. But I saw in the workshop manual that these run a resistor. So the ECU, it has 2 circuits, a direct circuit, which gives the pump full power, and then a circuit through a resistor. That minimizes the voltage to the pump, so it reduces fuel pressure. So I first checked the voltage at the pump with the car running, and it was 6 volts. Now that's really low. I'm surprised the pump even spun at that lower voltage, but it was running. So we can't tune with that. It's not going to work. We need constant, reliable voltage at the pump. We don't want any variable voltage. So I bypassed the resistor, and then that went up to 10 point something volts. Can't remember exactly. That's still not enough. That's with the car running. So battery voltage with the car running was 13.3, around there, 13.3 with the alternator charging. So 10 point something volts still was no good. Then I cut the circuit that triggers it to go through the resistor circuit. and that gave me an extra volt. So we got to 11.2 volts. So aside from that, I can't do nothing else but to rewire the whole circuit. So we've got a relay. I can't use the factory relay because the factory relay has the two circuits where it goes through a resistor and it goes direct. But that relay gets powered from another relay that gets powered from another relay. And so I have a feeling that because we're still sitting at 11.2 or so, we're still dropping 2 volts. I have a feeling that it's because it's going through all those other relays and the circuit is really long. I think that's where we're losing our voltage. So we're going to rewire it. We're going to go direct with a relay, get the ECU master to turn it on. So at this stage, I was still letting the factory computer have control of that, but no more. So yeah, so we're going to wire it up and then we'll check our voltage again and check that we are getting our battery voltage while running, so being charged at the pump. Hello guys. All right, it's morning, the day before the cyclone arrives here in Brisbane. It's still, weather is still pretty good, it's pretty calm where I am. But anyways, last night I was here till late struggling with a problem. Now, struggle, it is in every sense of the word. I spent about 4 hours chasing this problem that when the car's idling and you select the gear, now this is automatic. You select the gear, it stalls. Maybe 60-70% of the time. The other 30 or 40% of the time, it struggles and it'll pick itself up and it would idle really low, but smoothly, but low. And then I'll take it out of gear and it will remain idling low. By low, I mean around 550 RPM. And then I'll stub the throttle while in park or neutral. I'll stub the throttle and then the RPM will come up to about 850, which is where I had it set, which is still a little bit too high, but there's a reason for that. And I could not for the life of me find out what was causing it. I checked all the logs for everything, for your idle, ignition, fuel, everything was spot on. And whenever we stalled, the logs did not give me any information as to why and what's causing and what's going out of range and so on. Hours I spent chasing this, and I think I figured out why. So I'll see if I can get it to do it again, to what I'm talking about. So it's idling really high at the moment. Oh yeah, I know why. I'll bring that down. Okay, so we're around 800 RPM there. The tacho is a little bit out. I'm going by the ECU. So we select the gear. See how it dipped really low and then it picked itself up. Now it's idling at 600, which is not bad. If I take it out of gear, okay, it's picking itself up again. Could be because the coolant temp is a little bit low. Let's try again. See, stumbled a little bit there. All right, it's making me look bad. Yesterday, I couldn't get this thing to stay idling after I select the gear. So that's out of gear. All right, so it didn't stall that time, but you get the idea. It's not normal. It should go into gear and stay running smoothly. Last night, it was stalling on me, like I said, 60-70% of the time. And what sort of made me think that there was something going on in the background is that sometimes it would, when it was staying idling really low, there was no reason for it. All my idle control settings were higher when it was idling low, and they were lower when it was idling high. Now, my polarity wasn't, it's correct. So I did check my polarity for the idle control motor. I did that way back into the setting up of the software, and that's all fine. So that can happen when you have your polarities wrong, but that's right. And so there was no reason. And then right at the end, when I gave up, I had nothing else, right? On my last startup, it stayed idling really low, so I put it in park and it was idling like a 550. And I'm like, just out of curiosity, I'll check what's the ignition timing doing. So I hooked up my timing light on, and it was sitting about, just to throw a number out there, 30 to 35 degrees retarded. The engine, that's what was idling. So I'm surprised it was even running. It was running that retarded. Now, there is no such thing on my tuning table for the ignition timing to have to go that far back. So that left me with a little bit of hope, because as you'll see now, we were struggling with detonation when we were tuning it, right? As you saw, as you just saw. And I couldn't figure it out. I took all the ignition timing out at that point where it was detonating, and I could still hear it. So that left me with a question. Is there something in the background still influencing the ignition timing? And there's one wire that I left, and I'll confirm this. I'll talk about this after I confirm that that's the problem. So I came in this morning thinking, okay, I'm going to try this. I think that's it. So we're going to try that now. I'll see if I can show with the timing light what's happening with the ignition timing when we select the gear, just so you guys can see what's actually happening there. And then I'm going to get rid of this wire that I think is causing the problem, and then we'll test it again. All right, guys, so got the engine running. I got George in the car. I got the timing light. I'm going to show you the ignition timing idling in park, and then what quickly happens when we select the gear. Have a look. All right, select the gear. Have a look at that. We're around 30 degrees retarded. Oop, bit close there. So that's our problem. Now I'm hoping that by cutting the wire that I need to cut, that fixes it. All right, hold it there. Oh, that didn't do it. Take it out, go park. Okay, put it back into gear. No, it's still done it. No. Okay, that didn't work. I'm gonna have to inspect further. Okay guys, so we finally got to the bottom of it. Finally. I must admit I was surprised in a way as to what the problem was, and I take no credit for figuring this out. I did have to reach out for customer support, which they done a great job They actually figured it out within seconds. Obviously, I had to provide the correct information as to what was going on, and as soon as I told them, they picked it out straight away. So the issue, and I'm going to go into detail here as to what happened. The issue was the trigger edge. Now, if you know a little bit about tuning, aftermarket ECUs, and then you'll know what trigger edge is, as it's part of the setting up of the parameters when you're setting up your trigger patterns and you know what type of sensor you're using and number of teeth and so on, right? So I've always known that it's important to get this right, but every time that I've done it, I've never experienced a problem when it goes wrong. Now, I didn't set this wrong. The problem was, and I'm gonna, like I said, I'm gonna go into detail as to what it was. The problem was a mechanical part in the engine that was causing the problem. So what was actually happening was the trigger edge was slightly going out of sync. So you got your crank signal, teeth count, and then you got your cam signal, which is your home, which in this case, it's just a one tooth. And what was happening is they were shifting when the RPM was at a certain point that the engine mechanically was moving, and so it was shifting from one side of my crank signal to the other side of the crank signal. And virtually what was doing, it was altering my ignition timing by, I think it was 30 degrees. I'll explain it on the diagram that I've done here. I'll try and explain it as best as I can. But yeah, so here is the diagram that I've done, and I'll explain more in detail as to what was happening. Okay guys, so as you can see on this diagram, we have at the top, we have our crank signal, which is 24 teeth in this case, and our cam signal is 1. It's marked as 1 in the green. So for every 24 teeth count on the crank, we have 1 home signal. That's telling the ECU when we've completed a full cycle. Okay, so now in this case, this engine, and this is not very common, this engine has a distributor. Both the crank and the cam signal are inside the distributor, which means that both of these are rotating in the one shaft. Every 4-stroke engine, the crankshaft will rotate at double the speed of the cam. So for every 2 revolutions of the crank, you'll get 1 revolution of the cam. But in this case, because both signals are attached to the distributor, both are spinning at the same rate. So 24 teeth on the crank, it's actually 12 teeth when we set it up on the ECU. We need to halve it. So, but we still, when we're looking at the diagram and we're looking at the information that the ECU is receiving, this is what it looks like. 24 teeth, 1 home. But in the ECU, we can tell it that it's 12 teeth per revolution. Okay, so then the ECU works out the rest. So now this is what my scope looked like. Now this is a great feature of the ECU Master ECU. It gives you a scope. Now I've drawn this, but it looks exactly the same when you scope it out on the ECU to check out your signal. So ideally, this is what it should look like. Now this is what my one actually looks like. So if you notice right here, you can see that my home signal, which is the green, marked as green, is slightly to the left of one of the signals on the crank. Okay, now at first, when I was setting it up and I scoped it out, I either had the option of being close to one side of the crank or being close on the other side. So I didn't have, it didn't give me an option or to have it exactly in the middle of two. Okay, so it was either close to one edge or close to the other edge. And what was happening is that at certain RPM, now for some, this is where I didn't understand, because both of them are on the same shaft. So I don't know how that signal was jumping. I would understand that if you have your crank signal from your crank angle sensor at the crank, and then you got a cam angle sensor, and then you might have stretch in the belt or stretch in the chain, and that can vary. And so that's where this is actually very possible, because you will have some slack in the chain, and it does move, But in this case, they're both attached to the same shaft, so I don't understand why this was happening, but it happened. So as we can see here, and I'll try and demonstrate it, what was actually happening is the signal was doing this as the engine was revving. So this was happening at idle, and it was also happening when we were driving it, as you saw, when it was detonating. So this was the problem. Now, the amount of degrees that it was shifting. Okay, so we have 24 teeth at the crank. Now remember I said we've got a half it because one revolution, sorry, that's 24 teeth for one revolution, but that's spinning at twice the speed as the cam. So we need to half our crank, which would make it 12 teeth. Okay, so we've got one revolution, the ECU is counting 12 teeth. If we divide 360 degrees by 12, we get 30. So each space in these lines represents 30 degrees of crank rotation. So as you can imagine, our home signal represents when the ECU sees, okay, we've completed a revolution, and it calculates its ignition timing. So as you can imagine, if we shift our home signal from one side of our crank to the other, we've effectively told the ECU fire 30 degrees later or fire 30 degrees earlier. Now we're lucky that in this case, when we saw the problem at idle, it was retarding. Okay, it would have been a lot worse if it was advancing. Now, why was it detonating if we're retarding 30 degrees, right? An engine normally won't detonate if that is happening. But if we understand a little bit more about detonation is usually when we got two ignitions happening inside the cylinder at different times, and those two flames, the ignitions colliding, okay? So what I'm thinking was happening is we got our normal ignition trigger, so the engine fires, but then in the split second, it shifts, and then the ECU would want to fire again. So we have our normal ignition timing, which was at that time, it was roughly around 8 degrees, very conservative when I do my tune. Once everything is fine, once I've tuned my fuel mixture, then I tune my ignition timing. So at this stage, we were still tuning fuel, so my ignition timing was very conservative. But we're looking at roughly 8 degrees of ignition timing. It would fire, then all of a sudden, we got another ignition happening 30 degrees later, and those two flames coming together, and I think that's the noise that I was hearing with the detonation. So that's what was happening there. But yeah, overall, this was causing the problem. Now, the solution that we came up with, well, really the only solution that we had was to change our trigger edge on the cam home signal. Now, that meant putting our signal from close to one edge to the other side, close to the other edge. No, sorry, close to one edge to close to the other edge here. So we're still within where it needs to be, but we're closer to the other edge now. Now that fixed it simply because when we had the problem, the way that the signal was shifting, now when we've changed our trigger edge, is shifting towards the middle of our two crank signals. We're not jumping the line. We're moving further away from the line. So we're maintaining within our two crank signals. And so now our timing is not shifting. So that was it. So once we sorted that out, we went for another drive. We finished the tune. It's running wastegate pressure at about 7 psi. So we left it there for now. George is putting his Ks down, trying to get around 1,000 Ks. Then we'll do an oil change, and then we'll go for another tune. We'll turn the boost up a little bit more. But this was it. This was the only issue we've had. Everything else has been perfect, apart from a little small coolant leaks that we tightened up a few hoses, and that sorted that out. So it's going great so far. Now I'm happy that this is sorted, and we can move on. So yeah, thanks guys. Thanks for watching. I hope you understood the explanation of what was happening here. I'm glad this happened. I learned something. Sometimes someone can tell you and teach you something, but unless you've actually experienced the problem, then you haven't really learned. And I knew about this all along, but it never crossed my mind because I had never experienced it before. So now I've learned something pretty good, and something that I'll definitely keep an eye on in the future. So yeah guys, so if you've enjoyed watching this, remember to hit that like, hit the subscribe for more cool projects. Thanks guys.